Hi, my name is George McQuinn, and I'm sitting here with TJ Rifkin and Coleman Bader. Welcome to our Calorimetry Lab Challenge. So, what is the purpose of this lab? This lab was designed to test the accuracy of the calorimeters we built while learning about the chemistry of how food is turned into energy. The goal was to make a calorimeter that could absorb heat made by the burning of food. The energy released by the flame would raise the temperature of the water efficiently with minimal heat loss, so the results were accurate. We did this by building our own calorimeters and comparing our results with the results of professionals who use much more accurate devices called bomb calorimeters. The first key to understanding our lab is knowing what calories are. So, what are they? Calories are a measurement of energy and pertain to any substance. Not only food, but also rocks, wood, and anything else has energy contains calories. The large calorie or kilocalorie is defined as the amount of energy needed to raise 1 kilogram of water 1 degree Celsius. These are the calories usually seen on food packaging. The other kind of calorie, the small calorie, is 1,000 times smaller than the big calorie and is the energy needed to raise the temperature of 1 gram of water 1 degree Celsius. Another commonly used unit of energy is a joule, which is 0.239 small calories. Now, in order to determine the calories in our food, we must use a calorimeter. A calorimeter is a device used to measure energy and allow the observation of changes that occur during chemical reactions. These devices are used to determine the amount of energy that is contained within any given substance. Our calorimeter is unique because it has two cans which have been conjoined to create a pathway for the rising heat. This heat moves directly to the base of the top can in order to heat the water as efficiently as possible. In the bottom of the can, we have a grill-like platform made out of aluminum foil that holds the food as it is burned. The open flaps on either side provide good airflow to the fuel.
Hi, my name is Coleman, and I will be going over the steps we took in completing this lab. The first step to complete this lab was building our own calorimeter. We built ours using two cans, one to hold water and the other was attached underneath for the food to burn it. So minimal heat would escape. We allowed space above the flame for heat to be contained. To start the experiment, the weight of the piece of food was taken and recorded. Then the food is placed in the bottom of the can on a small grill. Next, 60 milliliters of water are weighed and poured into the top of the can. The initial temperature of the water is taken and the food is set on fire. Once the food is completely burned, the water temperature must be immediately recorded for accurate results. The design of our calorimeter was fairly effective, however, it could have been improved in a few ways. The first improvement would have been to make the barrier between the rising heat and the water thinner, so as to not lose as much heat to the can. Another improvement could have been to insulate the calorimeter with foam so that less heat could escape from both chambers.
Here is an example of a calorimeter that we pulled from the internet. This calorimeter is measuring the amount of calories being burned in this liquid.
Next, we'd like to talk about our results. As you can see in the table, each food item as well as the can of water was precisely weighed. For example, the Cheeto had a mass of 1.24 grams and the can of water weighed 34.76 grams. This data was later used in our calculations. First, we calculated the theoretical caloric density. This was found by dividing the known calories by grams. Those numbers were given to us by Steve. Next, we found the experimental caloric density. The experimental caloric value was determined by taking the amount of water in grams that we used, which was 60 milliliters, then multiplied the density of water, and then multiplied that by the changes in temperature of the water. Next, we calculated the carbohydrate and fat percentages. We determined the fat percentages and carbohydrate percentages through using the calories and mass of our food, and then plugging them into linear equations.
We also determine the efficiency of our calorimeter by dividing the experimental caloric density by the theoretical caloric density and then moving the decimal place over two places in order to get a percentage. For the Cheeto, for example, the efficiency of our calorimeter was 16%. When averaging all of our percentages, The average efficiency of our calorimeter was 12%.
This leads us to our discussion. The first question is, how was the work that your group did similar to the work done by professionals in the field, and how is it dissimilar? The work that we did in this lab was very similar to that of a real scientist. Our process, measurements, and data were much like those of a professional. The main goal of our lab was to determine the amount of calories in different foods, and this is exactly the goal of a real scientist working in the field. Another similarity to a professional is the design of our calorimeter. A huge part of the science industry is designing technology and tools with which to do experiments. Critically thinking about the design of our calorimeter is a great practice for potential careers. The difference between what we did and a professional might have to do with the fact that a real scientist would have more resources at their disposal. For example, they would have a more controlled environment and a bomb calorimeter with much higher efficiency than our soda can calorimeter. Another question from the discussion is, what is the relevance and significance of this type of investigation and the corresponding results? This investigation is relevant because every human being consumes food and drinks that are full of calories to give them energy. When we are trying to live healthy lives, one of the most important aspects of physical health is a diet. In order to create a balanced diet for our bodies, we must recognize the type and amount of calories that we consume. Every food doesn't simply have a number of calories printed on it, so we have to figure them out sometimes. Finding the number of calories contained within different foods is where calorimetry comes into play and where our work in this lab becomes relevant. If we could have done something different in this lab, we could have done quite a few things. The first improvement is we would have spent more time researching and designing our calorimeter. We went into the lab with minimal knowledge of how to make an efficient calorimeter, and we kind of winged it. We only spent about 30 minutes designing and constructing our calorimeter, which we regret. With more research on how to insulate calorimeters, what makes them the best conductor, and how to channel the heat into the water efficiently, in retrospect, we would have been able to construct much more accurate devices. Another way that we could have improved this is to have a better method of igniting the food. We used a cigarette lighter to ignite our food, and depending on the food, it took over a minute just to set on fire. The problem with this method is that the water could have been heated by the lighter and not actually the food, which may have skewed the results. Possibly using a blowtorch or something to quickly ignite the food could have greatly increased the accuracy of the results. Another possibility is to preheat the food so that it's ready for ignition. Another question is, what would you like to research or experimentally investigate related to this work further? We would like to research more about the calorimeter. It's very interesting to all of us, the design of the bomb calorimeter and its efficiency. We would like to attempt to design a calorimeter even more efficient than the current bomb calorimeter. We are also curious about the different types of calories and how they affect our bodies. We didn't feel as though this project went very in depth about the different types of calories, and we'd like to learn more about creating a balanced diet and adjusting this diet based on physical and mental activity.
This is Coleman Bader, TJ Rifkin, and George McQuinn, and thanks for watching our Lab Calorimetry Challenge.